Okay, so now we're going to talk about the one-to-one property of logarithms, and it's very similar to the other one-to-one property we had of exponential equations. So if we have a log base b of some argument m, and it equals log base b of some argument n, and that's all you have. You don't have anything being added or subtracted or anything like that. You just have the log on this side to the same base as the log on that side to the same base. Well, then the arguments have to be equal to each other. If those two things are going to be equal, then m equals n. And you can go the other way as well on that. So it's like that. So if you have like a natural log of x equals the natural log of 5, then x has to equal 5. So it probably makes sense when we put it in a simpler form like that. But notice that the bases are the same. They were both natural log. And you just have one log on the left, one log on the right. Bases are the same, so the arguments have to be equal to each other. Okay, so now we'll use that. Uh-oh. Something didn't get erased. Ignore that. Look away. Okay. That's fine. Okay, so we have this situation where the natural log of x squared equals the natural log of 2x plus 3. And it doesn't have to be natural log. It could be, they could both be common log or another base. The bases have to be the same though. Okay, so we're going to pop out those arguments. We're going to say x squared has to equal 2x plus 3. It's a pop-out thing. You're not applying a function. You're just saying, hey, if these two logarithms that have the same base are equal, then their arguments have to be equal. Okay, this now is a quadratic equation. So we're going to get everything on one side, set it to 0, and this factors into x minus 3 and x plus 1. And so we get x equals 3 or negative 1. Now, whenever we have a logarithm, we have to check and make sure that it doesn't make the argument negative, okay? So we'll rewrite this. Natural log of x squared equals natural log of 2x plus 3. And what we're checking to see is if we put in a 3, and since I have two logarithms, I'm putting 3 in both places. But is this a positive number for the argument? Yeah, 9's positive, so that one's okay. Now, 2 times 3 plus 3, is that positive? Yeah, that's positive. So the 3 is okay. Now let's check the negative 1. We'll write it like that. Okay, so you get negative 1 squared. You get the natural log of 1, and that's positive, so that's okay. And then over here you get the natural log of negative 2 plus 3, 1, which is also positive. So yes, that one's okay. So both of these solutions work. Sometimes you get one that makes the argument negative, and then you have to throw it out as an extraneous solution. Okay, that was it for that.